Let's begin our last unit of accelerated geometry, a unit on probability. Our lesson today is called TB or not TB, as we deal with taking a look at data and determining how we can interpret a set of information from some data as we take a look at some medical information. And we want to determine how to estimate conditional probabilities and interpret the meaning from that set of data. So we're going to take a look at TB, tuberculosis. And it can be tested in a variety of different ways. One of those is a skin test. If a person has tuberculosis antibodies, they are considered to have TB. Here's a tree diagram representing data based on 1,000 people who have been given a skin test for tuberculosis. Now keep in mind that it's very important in the medical field to interpret information and be able to take some set of data and share what that information means to a patient. So we have all this information here, and we need to be able to determine whether this test is accurate or not, so that the medical people are able to share some accurate results and confident results to their patients. So take a look at this information and answer the three questions below. Keep in mind this statement tested positive, and this little line, and then TB. That's a conditional probability. It's saying that they tested positive given that they have TB. So here when we see this branch patient has TB, it tells how many that had it, how many did not. And then among those that had it, how many tested positive, how many tested negative. And those who didn't have it, how many tested positive and how many tested negative. So use your knowledge that you have and the information that you're given on this table, this tree diagram, to write several probability statements based on the numbers, such as, give a percentage, or you'd say, out of what percentage were there this number of people. I'll look over those statements and write an asterisk next to those that are conditional probability statements. And then part of understanding the world around us is take information, make sense of it, and explain it to others. So based on the statements you came up with, what would you say to a friend considering the validity of the results if you're testing for TB and only get a skin test? So be sure to use this data to best inform your friend. If they tested positive, can they be sure they have TB? If they didn't test positive, if they tested negative, does that mean they don't have it? How accurate is this test? And share that with your friend. So pause the video now, take time to answer those, and restart it once you're ready to see some of the answers I came up with. All right, so here's some of the information that I found. A couple probability statements. 38% of the people tested had tuberculosis antibodies. 36.1% of the population tested had TB antibodies and also tested positive. 6.2% of the population tested positive but did not have TB. And 1.9% of the population tested negative but had TB. Some other ones, some conditional statements that I came up with. 10% of the population that didn't have TB tested positive. 5% of the population that had TB tested negative, so 19 out of the 380. 85% of the population tested positive actually had TB, so the 361 out of the 361 plus 62 out of the two totals that tested positive. And 3% of the population who tested negative, so these two groups who tested negative, only 3% of those actually had TB, so 19 out of 5, or the total of 19 and 558. So this tree diagram is helpful that we can organize that information in that way and get some probabilities and make sense of this information. And if we're helping a friend out who's taking a look at the validity of the results when they get a skin fold test and only a skin test, what would we tell them? Well, I think we would be pretty confident that if they tested positive, that they would probably, if they tested positive, they actually had it. Well, that's an 85% chance. So that's a pretty positive test. They would probably want to have another test done to make certain, because there's another 15% that well, they might not have it. But if they test negative, and that's the 19 and the 558, if they test negative, it's a good chance that they probably don't have tuberculosis, because only 3% of those who test negative actually have it. So it's pretty accurate, but you might also want to consider another test just to make certain that it's not something else as well. But you can see that it's based on the information that we have, it's if you test positive, there's a good chance that you have it. But if you test negative, that's a better chance that you don't have it. So if you were to test positive, you may want another result just to make sure. But if you test negative, it's pretty safe to say that you don't have it. So a couple other questions to consider as we finish up. Questions 4 through 7. Why don't you read through those, answer those on your sheet, and restart the video when you're ready to take a look. All right, so let's take a look at these questions. Question 4, in this situation, explain the consequences of errors. Well, that's where we talk about the false positives. So a false positive is where it says you tested positive, but you don't actually have it. Or a false negative where you test negative and you do actually have it. So what's the problem with those? A false negative or a false positive? Well, if you test for it, let me start over. If you test negative and you think you don't have it, well, you could actually be sick and you might actually get sicker. But if you test positive, you might think you're sick and maybe you're actually fine and you get treatment that you don't really need. Or maybe you have another sickness that isn't getting treated because you thought you have tuberculosis. So there are some problems there with both scenarios, which is why you want to be pretty certain on your test. Number 5, if a health test is not 100% certain, why might it be beneficial to have results lean more towards a false positive? So why is it better that we think we have it instead of results lean more towards a false negative where you don't think you have it but you actually do? I think that's pretty obvious there. Well, it's better to think you're sick and get the treatment than, on the other hand, to think that you're fine and you don't get any treatment and you'd actually maybe get sicker. 6, is a sample space of 200 enough to indicate whether or not this is true for an entire population? I'd say not enough information. We need more data. In our example, we had 1,000 people. 1,000 is a big number, and the more numbers you have, the more accurate and valid your test is. It's just the law of bigger numbers. If we have big numbers, it's better to test. You can think of it this way: like if you're shooting free throws, if you shoot 2 free throws and you make them both, well, you've made 100% of your shots, but I wouldn't necessarily trust you when the game's on the line because you've only taken 2 shots. I'd rather see out of 100 shots and see how you've done over time. Maybe you just got lucky on those 2 shots. So same with other data. We need more information to make it valid. Then number 7, how would you answer the young adult who tested positive and says, do I really have TB? Well, according to this statement, I'd say I'm 85% confident that they do have it, based on the results. Those who tested positive, 361 out of 423, which is about 85%, actually do have it. So it's a fairly confident that you have it, but there's still room for error there. So that's all the time we have in our lesson. When you get to class, I can help answer any more questions you have on these 2 previous pages. But what you're going to do is start working on reading Venn diagrams and creating them. So you'll work through reading and answering the questions associated with the Venn diagrams. And then you're going to interpret a tree diagram like we did in the example in the lesson, and make observations of probability based off of those. So you'll have time in class to work on that, and I can help you with that if you have any questions.